Okay, so more vocabulary for circles. And this picture here goes with these three definitions or rules. Okay, the first one says an angle whose vertex is on the circle and whose sides contain chords of the circles. Okay, it's talking about this angle right here. It could be this angle or this angle, but we're going to say this one because it's here beside the word. Notice that the angle is starting from the edge of the circle. The difference between this angle and the central angle is that it starts at the edge of the circle. The central angle is different, okay? This is called inscribed angle because it's an angle inside the circle, but it's touching the edge of the circle. And there's a rule about that angle, and we will talk about that rule, but it's different from central angle, okay? The next one says an arc that lies between the two lines, rays, or segments. So on this one, it's talking about the arc that's coming from the angle. Okay? That is called the intersected arc. I will tell you that this arc is always twice that angle. It's not equal like it is on the central angles. Okay? So if you do 2 times the angle, you'll get the arc. And so that's different from central angle. The next one is a word that you probably won't use. It's called subtend. It's just in the vocabulary listed with this, so I wanted to go ahead and tell it to you. But it's an arc or a chord, and what it does when the angle and the endpoints of a chord or arc lie on the sides of an inscribed angle. So it's a word that you might see, and here's how it affects the angles and the arcs. These two right here are the really important two. Okay? This is like a rule or a theorem. Okay? It's called the measure of an inscribed angle theorem. A theorem is a rule that has been proven to be true, and so instead of just definitions, we might have theorems. And this is what I was trying to tell you up here. 2 times the angle was the arc, or a half of the arc equals the angle. So you can write it that way. You could also write 2 times the measure of angle ADB equals the measure of the arc. So there's 2 ways to write it. Both of them mean the same thing. You either take half of the arc to find the angle, or you take the angle and multiply by 2 to get to the arc. And that's whenever you have an angle on the side of a circle, which is called an inscribed angle. Okay, another one or word is called an inscribed polygon. This is saying that we have a polygon. A polygon is just a figure with several sides. It can be 3 or 4 or 5 or 10. It can be how many sides it wants to. But it's a polygon that's inside of the circle, but the vertices lie on the circle. So inscribed means it's inside of it. Alright, the circle itself is called circumscribed because it's outside of the polygon. Okay, there's a rule about inscribed polygons. It's called the inscribed right triangle theorem. And here's what the theorem says. If a right triangle is inscribed in a circle, so you have a right triangle inside the circle, it can only be true if the hypotenuse is the diameter. Okay? You can only have a right triangle in the circle if the hypotenuse is the diameter. If the hypotenuse is not the diameter, it can't be a right triangle. Okay? So if you see that the diameter is one of the sides, most likely this is a right triangle, and this right here would be 90. Okay? And what I learned up there, if that's 90, that means that the arc that would connect it from A to C, that would be 180 because it has to be twice the angle. Okay? We'll look at some more problems like that in a minute. Okay, next is the inscribed quadrilateral theorem. So a quadrilateral can only be inscribed in a circle if and only if the opposite angles are supplementary, which means the measures are equal to 180. What that's telling you is that E and G, if I add angle E and G together, I have to get 180 because they're opposites. If I add D and F together, I have to get 180. Okay? So opposite angles for quadrilaterals have to add to 180. Okay, next is the tangent. And intersected chord theorem. If you have the tangent and a chord that intersect at a point on a circle, then the measure of each angle is 1/2 the measure of its intercepted arc. All it's trying to tell you is that if this is the tangent and this is a chord, that still, if I know angle 1, that this chord right here is twice the size of angle 1. That's what it's telling you. And we'll look at some problems that will show you that. But it makes sense. That's kind of what it was saying up there when it talked about it. But that angle is just half the size of that arc. And same thing is true about angle 2 in that arc. Angle 2 is half the size of that arc. We'll look at some problems about it. The last two are just two more formulas that you have to know. So these are going to be really helpful for you as you're doing your work, because both of them are formulas. This is called the angle inside the circle theorem. Basically what it says is that if I want to find angle 1, that I'm going to take these two arcs across from angle 1, I'm going to add them together and multiply by 1/2. Okay? If I want to find angle 2, I take the two arcs around angle 2, add them together, and multiply by 1/2. Okay? So those two problems are not, the problem is not going to be a hard problem. You just have to know that formula and know how to use it. And we'll do some problems like it as well. Alright? And then this one is called, it's the same kind of theorem, angle outside the circle theorem. Again, it's another formula. And here it's telling me if I want to find angle 1, that I take the two angles that are sort of connected to angle 1, and I subtract them, and then multiply by 1/2. So up here I add them, here I subtract them. That's the difference between these two. And looking at the picture and looking at the formula, I think will help you as you're doing these problems. Okay? Alright, so keep those out, because you're probably going to want to come back to the formulas and to the problems as we do some problems here. Okay? So 1 through 6, what 1 through 6 is kind of helping you understand is how to find the angle when it's coming from the side of the circle. Okay? And what our rule was this rule right here, that the angle and the arc are not equal, but the angle was half the arc. And that's pretty much what's going on these pictures right here when we're trying to find them. Okay, here it tells me that this arc is 84, and it wants me to find angle A. Since this is coming from the edge of the circle, I'm just going to divide 84 by 2. And so I know that angle is 42. Okay. Here, it wants me to find angle G. It's wanting me to find this right here. Well, in order for me to find that, I need to figure out this, because I know it's going to be half of that if I can figure that out. Okay, look at what they already have for us. They've got 70 here and 120 here. So this rest of the arc is 360 minus that, because 360 is the whole circle. So I'm going to take 360, subtract 70, subtract 120. I get 170 for that arc. So to find G, which is across from it, again, you just divide by 2. Okay. On this one, it says for me to find the measure of the arc. So instead of going from the angle to the arc, I'm going from the arc to the angle, I'm going from the angle to the arc. And what I know is if the angle across from it is 30, I'm going to multiply by 2 to get the arc across from it. So if I multiply that by 2, I'm going to get 60. That's not what the question's asking me, though. The question said to find VU. The question wants to know what this is. Okay. Well, again, I can tell that that's a half of a circle here. If that's 60, what am I going to do to find VU? Subtract from 180. So 180 minus 60, and you get 120. So 120 is the angle we're looking for. Okay, so here we're trying to find angle N, okay, which means I really need to know this little arc right here at LN. I see we have a diameter here, so I know all of this will be 180, so I really need to subtract 180 minus 60 to get that arc, which is 20. It's asking for the angle, so I divide the 20 by 2 to get the angle, not by 10, by 2. And so the angle we're looking for is 10. Alright, here we have an angle, and it's asking me to find the arc RS. Since that one's the one across from it, I'm just going to take 67 and multiply by 2. And I get 134. And then here it tells me to find WX. I already have this side. Well, if I could figure out this, then I know that I could figure out the WX. So I'm going to first figure out WY. And I can see that that's 75, so WY is going to be 75 times 2, which I think is 150. So that's 150. This part's 110, and I really just need to subtract all that from 360. So 360 minus 150 minus 110, and 100 is the arc that we are looking for. Okay, little bit more with arcs. So number 7, it says to find the angles that we're looking for. And this is a little different because they've got lots of different things going on here, but I just wanted to show you those. So it says to find angle T. Well, here's angle T. I can tell that here's the arc across from it. So that one's pretty easy. I know that I can divide 48 by 2. The next one says find QR. So it wants me to find this part right here. Notice there's not an angle coming from QR. So that means I need to figure out what I can see. There is an angle right here that's 50, which means I can figure out this part right here. So if that's 50 and I want to figure out across from the 50, and I'm going to multiply that by 2, that's 100. And here's the diameter again. So I know all of that's going to be 180. Well, if that's 100, that means this other part of the arc, which is what we're looking for, is 80. So that's 80. So there's a lot of things to be looking for when you're doing these. You're looking for angles across from it. You're looking for diameters and where there's 180. I think that's what, if it's difficult, I think that's what makes it hard, is there's a lot of things to be looking at. Okay. Okay, so there's 2 arcs that's asking me to find. It's asking me to find RS. And then it's also asking me to find STR. And so let's find RS first. There's a couple ways that you can find RS, but notice that there is an angle across from RS right there. So since that angle's across from it and that's 31, then for me to get RS, I can take 2 times 31 and get 62. Now, interestingly enough, I want you to realize that RS right there is also connected by this angle. You see that? See, there's 2 angles that connect to RS. That means that this angle would have been the same as the 31 if it did ask for it. Okay? Because there's 2 parts connected to that angle, or to that arc. So as long as there's angles connecting to the arc, those angles are going to be the same. Alright? Let's figure out what the rest of the question asked me. It said for me to find the measure of angle STR. Oh, yeah, that was the angle we were looking for. The same angle I was asking you about. And that angle is 31. And it's just kind of recognizing that there's 2 parts coming from that arc that are the same. Okay? Alright, number 9. Measure of angle 70, E is 75, and it says to find the measure of angle F, which is kind of interesting because there's no lines on this side, so it must be this angle here that it's looking for, which means the arc that connects it is this one. So if I can find that arc, I know I can figure it out. Okay, so let's just see what we can find here. Using that 75, because if this is, let's go back to F just a second. If this is F, and these are the 2 lines that make F, that's got to be the arc that I'm looking for. Okay? Now, it told me 75. And 75 is this angle, which is this arc. What do you notice about the arc across from 75 and the arc that I'm looking for? That's the same thing, right? It's just coming from 2 different places. So that arc that I'm looking for is across from 75. It just looks at a different place. So I'm going to take 75 and multiply by 2. That's this arc. That's not really what it was asking me though for. It was asking me for that angle, which these 2 angles are the same because they both are connected to the same arc. And so it's 75. These two questions are actually relatively easy, but I think they're hard sometimes to see how those angles are connected to the same arc. Okay. Alright, 10, 11, and 12 are very, very similar. It's just that we have a tangent line, and because of that tangent line, it makes it a little bit easier because we know that there's a 180. Like I know that this angle and this angle add to 180 since we have that tangent line. But the arc, the part about the arcs are still the same. Okay? It's showing me here that 210 is this arc. Well, see, that's still across from angle 1. So what would I do to get angle 1? Divide by 2. So it's 105. So still the same kind of stuff. It just looks a little different because we're talking about a tangent line. Okay, here it wants me to find RST. RST. 98 is across from that. So what am I going to do? 98 times 2. Okay. Over here, it wants me to find XY. Couple ways you can do it. I can multiply, like here is the 81. I can multiply that 80 by 2 to get this side. And then how would I get this side if I figured out that side? The whole circle's 360. So 360 minus 160. And I get 200. So all the ones we just did were the ones talking about the angle and the intercepted arc and trying to look at the arc and the angle. Okay. Now we're looking at the polygons, and whenever you have an inscribed polygon, the angles across from each other have to be 180. Okay, and that's what this is saying. And if it's a triangle, then I know that that has to be the hypotenuse. Okay, so let's look at these questions and see how that relates to the problem. Okay, so if I'm trying to find, I've got this quadrilateral. If I'm trying to find M and N, they're just across from it. So I know that N and 100 have to be 180. So basically I'm just going to subtract 100 from 180 to get N. I know that M and 65 have to be 100. I mean 180, sorry, not 100. And then I'm just going to subtract 65 from 180. So basically you're just saying that ones across from each other have to be 180. Okay? So in 14, a similar thing is going to happen. We're going to say that these two across from each other have to be 180. So 5x plus 110 equals 180. And then we're just going to solve that equation. We're going to take 180, we're going to subtract 110. And then we're going to divide by 5. Same thing happens here. 2y plus 104 equals 180. So subtract 104. And then divide by 2. Basically just take the ones across from each other, set it equal to 180, and solve. Okay, number 15, it says determine whether AB is a diameter. And that's what the right triangle one was telling me, was it's a diameter as long as this is a right triangle. Okay, so it would be a diameter if That right there is 90 degrees. And so that's what we've got to figure out. We're trying to figure out, is that true? Is that 90 degrees? Okay? And so, alright, so let's look at the arcs and see if that helps me. So I know that this is 30. Okay? Across from 30 is this arc. I know that's twice it, so that's 60. Alright? 60 and 120 make 180, so that means this up here's got to be 180. So is that 90? If this is 180, is that 90? It is. Because that angle's got to be half that size, because that's connected to it. Here's the sides of it, and so that 180 is connected to it. Okay? Okay, look at these first. So the first one says to find angle ABC. It's asking for this angle right here. And if I know that this is 70 and that makes a 180 because that's a tangent, I'm going to do 180 minus 70 to get this right here. Okay, so I know that this is 110. Okay, then it says for me to find arc AB. See, that's across from the 70. And so I know I'll multiply by 2, and that would be 140. This one over here is asking me to find A, E, B, which is pretty much across from the 110. I could multiply 110 by 2, or I could subtract 140 from 360 since that's the whole circle. Whichever way makes sense. And so you get 220 on that one. Okay, let's look at this one. Let's first of all figure out what they gave me. ADB. I think D is supposed to be right there. So ADB. So if I go this whole entire thing, that's 220. Okay. They also told me that B is 21. So first thing they want me to find is AB. Alright, before I find AB, let's see what else we can find here. With that's 21, what's this little part here? Multiply it by 2, so that's 42. Okay. Now, if I wanted to find AB, and I know that 220 goes from A all the way to B on this side, I can do 360 minus 220 to get the AB part. So I know that this over here is 140. Okay, then it tells me to find angle ACB. So here they're asking me to find this angle right here. Okay? And that angle is connected to this arc, the 140 arc. So it's half of that arc. And you get 70. Alright. The very last 3 problems are those last 2 formulas that I gave you on your notes. Okay? So the number 6 is the one that says you take half and you add the 2 arcs together. Okay? So the 2 arcs across from X are these 2 right here. So I'm going to take half and add those 2 together, and that gives me the answer. It's just a formula to know. And you get 71. Okay, the other one says whenever the angle's outside, and that's what's going on both of these, the angle's outside, that you take half and you subtract the 2 arcs. Okay? So here's the angle, and it's a half and subtract the 2 arcs, So we actually have to solve that equation. Since they gave us the angle, that's kind of where we're coming from there. So I would multiply by 2 first, I think. When you multiply by 2 on both sides, that gives you 76. And it makes all that go away. So, let's see, did I do that right? Yeah. Subtract 72 on both sides. You know what? I didn't do it right. I knew something wasn't right. I did it backwards. I'm sorry. I'm going to do it up here above it. 38 is a half, and you have to do the biggest arc minus the smallest arc. So x minus 72. Sorry about that. Still, I want to multiply by 2. But then I want to add 72 on both sides. Alright, very last one. It's different from this because it's got this thing going on here. Okay? What I can tell is that if this angle is 130, and notice that's coming from the center, then I know that this is also 130. And then that means I can find all of this out here if I want to. So I can do 360 minus 130. So all of that is 230. And then now I can do what I did here. I can say 1/2 of the big one minus the small one. As long as I know the two arcs, it's just 1/2 minus it.